need books, help, artificial legs, artificial eyes, whatever the hell they need. Do you understand that? Guys, well, what's the matter with a monument? He's a monument builder. He's sincere, but he's ignorant. Do you understand that?
Yes. Yes.
Any questions about that?
No, that's a really good point.
I have nothing I'm not against this. I'm just against it in a world where you have limited resources. Now, here's the city again. It's round, not because I like round cities. If you have a production plant that produces automobiles, this is called linear. The production lines run that way. All I want to do is make a center where the planning engineers for automotive transportation work. So this is a production line. This is a production line for trucks. This is a production line for Jeeps. All of these production lines come out of the central planning area, like this. Do you understand the drawing? They're not necessarily 8. There may be as many as needed. But this end of the factory is up off the ground, so's the rest of it. And the vehicle that picks up the finished products travels and picks up in 20 factories and delivers materials to the factories. Now, if you want to see anybody, go to the central planning. These are the guys that plan all the production lines. But if you build a factory in Detroit like this, then you build one over here, Toyota. You got another factory over here. Your trains have to go all over the place to pick up things. In the free enterprise system, these are all separate companies. Here we share ideas in production. Do you understand that? It's got to come out cheaper. It's got to provide more cars than this system. Now, another thing. This is so you'll have arguments to win over ordinary people. If you look at a railroad yard today, you'll see lots of tracks with hundreds of freight trains sitting there. And they hope next month orders will come in so those freight trains will be in use. We always have all our freight trains in use. There's no such thing as downtime because it's a co-op. Do you understand that?
Yeah.
If you don't do that, you'll always have trucks sitting in yards hoping that orders will go up next month. These are vehicles. They don't need to rest. Trains don't need to sleep for 3 nights in a row. So we have our factories going night and day. And you have a swing shift until it's automated. The reason for it night and day, you got a bunch of machines. If you turn it off at night, the machines don't need to rest. You can turn it off once a month for servicing. That's all right. Or a night, 3 nights or 5 nights of servicing. But if you don't do this, if you do what they ordinarily do, you have to take my word for it if you don't know this. If this is a factory, and this is the parking lot, or this is a shopping center, and this is the parking lot. If you make a shopping center round, that's shoes, this is furniture, this is stuff to eat, whatever you got here, you park adjacent to where you're going. In this system, you walk through the whole shopping center, and then you have to go back to where you started. In this system, you start here and you always come back to where you're at. So it's cheaper for automobiles to park in adjacent areas. But if this area is larger, more people are going here, you have movable walls. So they slide, and in the shopping of food, say it's larger, you roll your walls over. Do you understand what I'm saying? This way you build a factory, and if business is bad, it closes. You move your walls up and back for different changes in production and need. And you have round factories with walls that travel on rails up and back, and each size can be varied depending on how you're doing. If you're feeding enough people, you can move your wall over and make it smaller. If you don't have enough food, you make it larger. Is that real clear? This is the detail I don't give out, because people will patent it and start using it, and they'll make money on it commercially. So I don't like to give out detail of how the system works. When I talked to you about the airplanes, I think if the landing gear fails, all that's patentable stuff. And I'd like it to be part of the new economy. Now, if Detroit does this, in an automobile, Toyota will do the same thing. And then Toyota, if the Toyota does it, I think they can beat Detroit in a little more ingenuity. And so here, Detroit is up with a big factory that's automated, which they can't sell. If Toyota can turn out the same product cheaper, you can't sell your factory. Do you understand
Yes.
that? If you have a factory that turns out refrigerators, and you have a factory that turns out, if you're 10 times as fast as this guy, you don't want to share it with this guy, because you want to maintain the competitive edge. So this guy can't sell his factory, but he borrowed money from banks to build in this sort of stuff. So the bank says, how long will it take you to amortize the cost of that? He says, 4 years, then I'll change my production. But you've got better production methods. And he can't afford to keep borrowing money from banks and updating his equipment. That's why the free enterprise can't keep up with things. But when it belongs to the public, what you really need instead of a production line is machines that can change their function to mass production, modify them, make them so they're flexible. Do you know what that means? If you don't know what it means,
Less moving parts, more maneuverability
you know
to do
what jigs and fixtures are in industry?
No?
Like they have tube bending equipment that'll bend pipes of different diameters.
Yes.
All right. So what you need is dies that can bend pipes any size so they can get smaller or larger instead of a fixed production system. That all machines of steel will be designed for maximum flexibility. Instead of people welding things together, which takes time and money, if you don't understand this drawing, this is a drawing of an I-beam. I'd like you to understand it. You understand that drawing of an I-beam? The I-beam has a thing sticking out on it, and it has what looks like a half a buck, very thick, sticking out here. And then the walls have a keyhole in them that look like this. And you stick this into the keyhole and drop it down, you don't need to weld it. And you can disassemble it faster if you've got better ideas. And you can use these beams over again in different ways. There are thousands of different multi-use products, but people that do welding make a lot of money. The system doesn't make as much money, but it'll knock the other guy out. And if you make buildings, let's say you made a building old-fashioned, and the memory metals are just in the joints right here and right here, not the whole building. So when you turn this in and that in, you deliver a thing like this, and then turn the memory on, and it goes up like that. The joints are just here, the memory metal, not the whole building. It's just in the joints. So if you turn the building in like that, collapse it, turn the memory on, it goes up like that, out. But people think I'm using memory metal throughout the whole building, just the joints. So when I say, yeah, but who's going to make the memory metals? The memory metals are extruded automatically. It's very easy to do. That's the way they do it today. So when people say to me, well, what's the matter with today's stuff? If you make a refrigerator round like this, and all the shelves rotate, you can't get to the back of your refrigerator. You have to take everything out to get to the milk bottle. If they're round, you rotate it, you fill all your stuff in. And you don't need to open the whole door, just this sliding area.
That's great.
You understand?
Yes.
All right, now, all the ovens, I think I mentioned this before, will have a pinnacle sticking up like that, instead of a heater coil. Your pots will have an indent in the middle sticking up, all of them. So if you're making soup, the heat only goes through the soup. Do you understand it? So you got a coffee pot here, and there's a pinnacle sticking up. The heating element is not in the pot. It's on the stove sticking up. So when you put the coffee thing, the heat only goes through the coffee. You know what that would save a nation in energy? Rather than a hot plate underneath it, where the heat goes all over the place. And you have to wait till the heat goes through the whole thing. Here it goes through faster. You'll save millions of kilowatts of oil, energy, electric generators, everything. But the electric companies would not like it in a private system. They'd rather sell the gas range or heat range in every apartment. I would rather make the apartments large and have dining areas for the whole community instead of housewife making bacon and eggs every day. I'd rather photograph Chef Milani making food and then program computers. I don't know if you know that. A surgeon has 10 tremors per second in the hand. Computers have none. So when they do surgery, they cut with a controlled depth. Well, the doctor has to do it first so the computer can measure his position in space. Then thereafter that operation, a doctor doesn't know anything. When he cuts a person open and it turns red, he says hemostat and he clamps that area. Where did he get that in medical school? If you teach a computer to scan for color, suddenly red blood comes out, the hemostat goes on it. See, a doctor says to a nurse, hemostat, the nurse gives him a hemostat right in his hand. Then he says clamps, the nurse gives him clamp. A turret head, when the doctor says hemostat, it turns and he takes it. Nurse, the clamps, blood clots, whatever the conditions are, he gets. Sooner or later, the material doing the surgery will scan, make sure there's no hemorrhage. And if there is a hemorrhage, it's immediate. The turret head turns and locks it. But a doctor has to look at it. Another student says, see, that's a hemorrhage. He's got to instruct people. Your computer or your laptop has a lot of information, but it's just a computer. In the future, the computers will be connected to industrial processors. So the computer doesn't say things without altering the production process. When the computer is connected to machines, it can say hemostat, this, that. So we're just looking at a world where computers are connected mostly to people. In the future, they'll be connected to industry, agriculture, so you'll know what the hell's going on all over the world. Right now, they talk about centralization. You know what that means? Decentralizing. Because when you have Washington, D.C. here, and this is the United States, Washington doesn't know what's going on in Florida, nor the state of Washington, nor New York. So they say, we want to decentralize, but with computers connected to Washington, Oregon, Florida, Key West, you know what's going on all over the country. And since you don't have any vested interest in Florida, there's no reason to decentralize, and you got to have computers all over the place. Here they're connected to the whole of America or the world, so you know on one central computer everybody has a model of the Earth in their home. When you get to Venus, I'll show you a model of the Earth and you touch it. It gives you the population, the Atlantic Ocean, the ice. It speaks as you touch different areas. Have you seen
The
that?
cybernated complex is what you
Yes.
call it, yeah.
Now then you can get the depth of the ocean, the production, ice formation, hurricanes, everything on Earth is in your home. So if you want to know anything about any state, you plug it in, you touch it. Or you don't even need to touch it, get in proximity of it, it'll tell you what's going on. Just like a little unit you move your fingers by.
And everyone will have access to that information. It won't, so like Wikipedia and that kind of stuff. It'll be...
Jack can't hear you.
Everyone will have access to that information,
Oh,
yes.
Well, mostly people that have concern about those things, that manipulate the environment. everybody wouldn't want that in their home. But guys who want to know, if I build a dam here, what's going to happen there 5 years from now? The computer extrapolate, tick, 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 based on known information. It says, if you build a dam here, it's going to cause a drought there 4 years from now, not immediately. The computer extrapolates. If you build 4,000 planes a month, there's no airport to receive 300 landings an hour. They can't. So it scans all the airports, then it tells you how many planes to build. But if you just build cities all over the place and food is way over here, how much does it cost to transport that food? So food has to surround each city, photoelectric cells, solar power. Each city has to be self-sufficient because electric lines lose a lot of energy over long transmission. Unless you produce absolute zero, there's no loss. But the energy to produce absolute zero costs a lot. You know what I mean?
Mhm.
So
I was going to say earlier that we will streamline production
but
as
you
much
know,
as we can.
just saying that, give them an example.
Mm.
But don't give them details.
Right.
Just say by having a central air conditioner, piping it to all the buildings better than one hanging out of each window.
Right.
But it's good for the electric companies, the other one. So I don't want a person making bacon and eggs every morning. I want Chef Milani, or whatever they call the best cook, to chop up onions and do what he wants, but photograph every motion he makes. If you're not familiar with that, I think I told some of you that the auto companies spray rubber under the metal so the rain won't drive you crazy. It deadens the sound. But a guy has to spray rubber under the car first, and the computer measures every move he makes and logs it in, see? And then thereafter, from there on out, the cars are sprayed automatically with rubber. Now if you teach, say 1A or 1B, we photograph you teaching. We photograph 99% of the questions kids ask and put in additionals. So he doesn't go to school every day and says the same thing to 1A and 1B. 2 and 2 is 4, 4 and 4 is 8. That's done automatically. His image comes into the class full size. Good morning, students. And he then tells them about history of the United States without propaganda. And he tells them, but he can be out sailing a boat. I don't want him there every day doing the same thing. You can go back to school and study advanced teaching systems, whatever you want. But if you do every day, get in and drill holes in metal, it's the same process. We can easily automate it. Yes.
Do you see this as a for education? I mean, surely that could solve
Yes,
all,
technical education.
but right across the entire globe, if you could have the best teacher, and
Photograph.
yes,
So he can have 40 schools
Yeah.
instead of one, yes.
and put
absolutely.
all those kids in Africa
By
and
getting the
Madagascar
best training.
on a some kind of route. Maybe they do it on the computer, but they go on a
We
on-
can't have good teachers go from one school to another.
Yeah.
It's cheaper to photograph them delivering like you're doing now. This lecture, I hope, if it's recording, will appear many places.
yes.
It won't change everybody because the language is not convenient for everybody. But done on multiple levels in the future, for coal miners, members of the Ku Klux Klan, each lecture has to be by a Southerner, by a black man to the black community, by a Polish guy to Poland. Like if I go to Africa, they invited me to Africa, and I'm lecturing to black people there, what the hell is Whitey doing here? You know what I mean? They'd rather hear it from a member of their own group with a foreign accent. France would love a Frenchman to do that. So that's where people are at, and that's what we must do. Is it the right thing? No, but it's the right thing for the present day. So the way I talk to the Klan today is not the way I talk to them a month from now. You understand that?
Yes.
It's an entirely ever-changing system. It has no fixed methods. This is the way you do it. This is the way we do it now because that's the best we know up to now. So don't ever talk of final frontiers or utopia or the best airplane or the best human arrangements. Humans will vary with the changing of the exterior. They will undergo change. And the change they undergo will be induced by the environment they live in. And like I said before, people will say, well, I like the future. If you took your grandmother to Miami Beach and she saw the girls with their butts hanging out, she's going to say, I don't like that. They've gone too far. And she's right where she's coming from, but not right for the new times. So you got to remember, it's not a question whether you will like the future. Are you educated to understand the future? So we hope to condition people to accept change, not get attached to New York City or old Paris with the Eiffel Tower. If you get attached to Greenwich Village, you know, it's charming with tables outside, you sit around over coffee and talk. You can become attached to anything, old cities, everything. We don't want people to be attached. We want to say, write to computer company and tell us what you want additionally. Well, I want my computer to be a camera too. I'd also like it to be an alarm clock. I'd like it to tell me what events are occurring in society that I might enjoy. Well, the computer engineer says, your computer can't do that until we put your value system into the computer. So it scans your values and tells you what you might enjoy. Do you understand what I mean? The computer will not be able to tell you anything. Unless you're interested in flying, sports flying, scuba diving, you put all your interests in the computer and then it'll notify you with a blinking light of an exhibit that you might enjoy. But also it'll notify you of exhibits you may not understand but will be relevant to your interests. Do you think you know what I mean? But it can't do that unless you talk to computer scientists in flying, scuba diving, skiing, water skiing, engineering, mechanics, and chemistry. The more you put into that computer, the more the computer will tell you what's available to him. So you can go back to school or you can go in the lab and work on things. You don't, in other words, you submit ideas to the chemistry department. They say, if they say, we don't think it'll work, you have access to any lab to disprove them. Because what people say is not necessarily true. So you have access. Like I said before, if you want to build your own airplane, we put a gadget in that airplane so you can't fly over cities with it. If it's your own design without approval, over ocean only. And if it's proven to be safe, then that gadget is taken out and it could be guided by satellite or flown by you. If you die of a heart attack, the plane is switched over to automatic and it lands at the nearest airport. We don't want to put people in passenger airliners that are only pilots. If they get a heart attack, the passengers all die. So we want to put 6 circuits in it on separate lines. If one fails, they always ask, what if the computer fails? They always picture one computer making decisions on everything. On an ocean liner, you have captains and you have people that can take over in case the captain dies. You have a lot of people. Then you have people trained to lower the lifeboats. You got all kinds of people on an ocean liner to handle contingencies that that ocean liner is subject to. Now, it doesn't handle media hitting it because the probability is 0. Do you know what I mean?
Yeah.
So when they keep saying who makes the decisions, just say no one, but we gather together information related to that problem. I think I mentioned this. When the ship is sinking, women and children first. We don't do that. We say, do you know anything about navigation? Get on the boat. Do you know how to catch fish in the open sea? Get on the boat, then women and children. Otherwise they'll all starve to death. Do you understand me? But we have little books that people go by, and we must verify that. Is that clear?
Yes.
Anything you don't understand?
No.
Okay, now, all the labs in the future have a bulletin board that's electronic, just like the airlines. Cincinnati at 4:15, have bulletin boards, and it says on the bulletin board, we've solved the problem of stroke. Now we can work on different brands of heart disease. Every lab will be blinking. When problems are solved, the next problem in line. Is that clear?
Mhm.
People don't want to know that you got a flat tire in your car. You want a machine in the car that keeps air in the tire and the blink when it needs servicing. So you drive your car to your house and your car will say, I'm going to service, and plug in. It's got its own plugs, 10 of them, plugs in, and the car analysis of what's wrong, the valves need grinding or whatever it is. You don't need a mechanic taking the car apart and say your valves need grinding. You know what fiber optics is? It's a bundle of glass fibers, and you put that crooked thing into a machine and you can see broken gears without taking it all apart. They have a gadget today, it's about this thick. They shove it up your ass, it goes into your intestines, and you can see the cancer, how spread it is, without cutting the guy open and looking. Fiber optics is used up through the nose, down the throat, into the lungs. So in the future, fiber optic and ultrasonic scanners. Instead of spraying plants with poison, we study the sound range of insects, way up to 80,000 cycles per second down. And then we study what insects are good for plants and how will that sound affect them. So we study the sound effects of insects, rodents that eat food, and we project that sound into the environment, so you don't need to spray poisons on plants.
Malaria? Could you talk about malaria as well?
Yes.
I've heard you say something before.
Malaria, 2 million people die every year in Africa of malaria. Now, so they spray the swamp with oil. Oil seals the water so the fleas, mosquitoes can't get out, the larvae can't get out, but the fish get no oxygen, so the fish die and mosquitoes. And the swamp water, the spray sinks down eventually and contaminates the groundwater. So what we do, don't discuss this, we have a light under the water and color band turning. And the color band is for the kind of insects you want to attract. So at night they fly right into the light and they drown. Do you understand? The light's under the water, not above.
I see.
If it was above, they'd hit and fry and die. So you can put it under the water. And thousands of malaria mosquitoes hit, the fish eat them, and you get more food.
Yeah.
Not just malaria mosquitoes, you get more food to feed people. That's the kind of research we do.
Are they doing that now?
No, of course.
Has anybody tried this technique? Has
I've
anybody?
got billions of different ideas, and I will not, if I gave it out, people will take out patents and charge you so much for doing that and so much for doing this. I want to release that if we get a global economy. If I don't, this system can perpetuate a little longer, and I'm not too interested in that.
Have you put these ideas in a safe place for
No, I've got them all over the place. I got thousands of things
Good.
in Venus, Florida.
Good.
But I want you to know that every aspect of the future, even concrete, like you see out there, concrete decks of buildings, we have an injector that injects particles into the mixture of concrete. And then it forms air bubbles all through the concrete, so it's 1/5 the weight. But where the concrete meets the metal molds, it becomes dense. So the center's core is full of bubbles, which is insulation, no condensation, lightweight, and stronger. And we use much less concrete if you have air bubbles in the middle. Solid concrete is not as strong as air bubbles in the middle. Did you know that? So if you do that, it's like in the old days, a pilot used to have a fire extinguisher in the cockpit. Well, if a plane engine caught fire, it's hard for him to put the engine on. So we have nozzles on the airplane at all areas where fire can occur. What you do is when fire occurs, the nozzle sprays. Do you understand that?
Yeah.
It's a thin pipe, you don't have a lot, on all areas of probable fire. That comes from studies of fire on aircraft.
Could you talk more about decision making in the Venus Project? Because
Yes.
a lot of people find it hard
Yeah.
to understand.
Okay. Who makes decisions? The question is, in what area? Agriculture, agronomists. Is that clear? Yeah. Is that clear?
Yes.
And or engineering and mass production engineers, or anybody else that has any ideas.
Yeah.
You don't need to be a production engineer.
Yes.
Fire safety hazards, safety engineers, there are people like that study that. Then there are people that investigate airplane crashes. It's called the FHA, the federal government has an agency, and they go and they look for whether the body was blown out by an explosion, or whether the engine failed, or whether a bird flew into the turbines. But airplanes are not rigged to generate a certain sound that'll keep birds away from the airplane. That's what's needed. So that goes blinking in every lab. What do you need for air safety? It lists a whole lot of things, and you start on that. You understand? So labs don't just work on anything. It's a survey committee that tells them what to work on. So it's never a dictatorship. Now it looks like to normal people that you're telling him what to work on. Where do you get it? From surveys. So it's not you dictating. Do you understand that?
Yeah.
Is Fresco there telling everybody what to do? No. It's telling them what they ought to do in order to come up with ideas. But if you see anything wrong with anything, bring it up. Does that make sense?
Yes.
Sure.
So there's no dictatorship in it. Now, who runs the whole system? With global connections to shipping, agriculture, you can see conditions on Earth. Every hurricane, every iceberg melting, the temperature all over the world. So your decisions are right before you. Now, you don't need a person sitting there. You can have electronic inserts